So we'll wait a few minutes for everybody to join. If you can log into Canvas and check out the course materials.
Good evening.
Hi, how are you?
Doing good. Just did some binary like yesterday.
Yeah, so it's gonna be a little bit like yesterday, but this class,
Like more of a math, like kind of like a math class.
this is a math class with the programming component. You will be programming in C++ with the math concept. So we will learn different topics like probability, counting, sets, stuff like that, and then we will interpret it by using C++. So as we wait for everybody to join, if you just got in, please check out, I'm trying to get my chat thing going. Please check out the Canvas materials, the first module. And then I will go ahead and open some of my files while we wait another minute. Okay, so the first module you will see is your course information. I'll go ahead and get started since it's 6 o'clock. So our class meets every week, 6 to 8, and I intend to do Tuesday as the main math lecture. We will cover some of the math concept, and then on Monday, that will be your math lecture, and then Wednesday, we will cover some of the programming part of it. So I'm going to go over the course details. So if you take a look at Canvas, you can follow along. I'm going to share screen. So the first part of this session right now is going to be your course orientation. I organize everything in module. And if you haven't taken my class, this is my 4th year at Moreno Valley College. Prior to Moreno Valley College, I taught at College of the Desert. I taught at multiple private schools. And I have done basically some IT work in the field as a technician, sysadmin, network admin, along with consulting for security. I currently run the business, but because Moreno Valley keeps me pretty busy, I haven't been able to come back to it in this last year. But prior to that, I do consulting. And so I do teach a lot of courses in cybersecurity along with programming. My wheelhouse is, application assessment, pen testing, stuff like that. And so for this course, what you're going to be learning is you are going to touch on some math concept that you might have covered in the other classes. Let me minimize the people here. And our class is 3 units. We are going to cover discrete math and some logic proof, counting graphs and trees. And then on the second day of the week, we will learn how to program that in C++, looking at recursion, how to be able to write functions for various goals in the program. And every week we're going to have different topics and we're going to learn how to program it. So as this course doesn't have a lot of requirements going into it, but at least I recommend that you have taken CIS-7, so you would at least know the basic C++. I will walk you through the lab and the assignment so you will not be in the dark. And if you miss class, you need to check out my video. I have a YouTube channel that I organized the playlist by course number. So you can check out the video on YouTube, or they will be also linked inside the class. So at the end of this session, I will post the video that recorded in this session. Okay. And so for the second part of this is going to be the Zoom information. And most of you have found this. This is where you would get the information to log into the class. I have a syllabus, so I'm going to go over the syllabus next. So for our syllabus, it gives you the course description. This is the structure for computer science. If you are majoring in math and science or computer science, you will be likely need to take this class. This class is transferable to Cal State and UC. In this class, we're going to cover functions, relations, sets, basic logic, proof techniques. So what you do in math, you can actually program it. So we will do various activities related to our math concept. The format for this is regular meet. So we will meet on Zoom. I've taught this face-to-face before. So we would treat it like a face-to-face, but using Zoom. And the content of the course is listed here, broken down into different categories. So to start, we're going to start with number system, looking at binary, hexadecimal, because when you begin your university journey, you will find that you need to have this basic knowledge going into some of the upper classes. This class teaches you how to solve problem with algorithm, looking at it from a mathematical perspective, so how to implement formulas and things like that, and be able to create a program out of that. So we will talk about logic, truth table. Starting this week, we're going to talk about truth table, actually next week, because we have the holiday. And then we'll get into proof techniques, recursions, looking at Fibonacci and counting. So things like permutations, looking at combinations of, different subsets or subgroup of data, and then how to use inclusion, exclusion principle, and going into probability. So a lot of the things that are listed here is math concept. So we wanted to be able to solve the problem mathematically and also programming wise. Then we're going to get into graphs and trees. And this is important, either aspect you look at it. So from a perspective of a developer, you can look at how nodes communicate. You can also build program to be able to track routes for flights, train system, bus systems, along with looking at, like the common problem is the travel salesman case, where if you're looking at which city that the salesperson goes to, you can map all of that out. And if you're looking at shipping company, this is kind of what they're using, is to look at how they route and track shipping packages from one location to another, when it gets transported to trucks or a delivery person, etc. So we'll look at directed graphs, undirected graphs, spanning trees, traversal, on how we can go different routes. And, if you get into more communications and networking, you see this on how system communicate, cell towers, things like that. So it's useful in a lot of aspects in our daily life, and also from our perspective that will be on the development side. And as I mentioned earlier, we'll touch on probability, looking at Bayes' theorem, randomizing variables, looking at how we can select something or combination. And the example that I like to use is, if somebody is trying to crack an ID or a password, how many combination is it going to be? So when you're looking at password cracking program, that is actually built by a software developer, right? And so it would look at how it's going to permutate through different combinations of characters, symbols, and things like that in order to crack a password. So we'll take a look at the probability behind that and how we would use counting or permutation in that type of scenario. So for the student learning outcome, these are the things that we will be able to achieve. We would be able to look at tools for logic and also real life situations, including computation context. And I have a course project in my class. So by the end of this class, you will write a C++ program that's gonna, simulate the situation for real life. One of the popular project is blackjack game, or the other one would be cryptography. So you would write a cryptography program and looking at how you would be able to generate cryptography text, right, encrypted text based on the shift in the key for our alphabet. So I'll walk you through on how to really look at that and how to solve that kind of problem. And this course is important as now I know a lot of university does coding camp before you start your program. So you have to be able to pass at a certain level to be placed in specific computer science class. So it gives you the foundation and, get you thinking about how you would solve a problem through programming. The prerequisite of this is CIS-5, but if you did take CIS-17A or C or other programming classes, that's a plus, so that will help you through the course. But I do walk you through each of the program explaining what they consist of. Any questions so far? Okay, so the skills that before you entering the course is just basic programming. Also to be able to use IDE. I am not particular to any IDE. Some faculty would use Visual, Studio only, or if they use like, some kind of IDE of their choice. I normally use online compiler. That's good enough for me. I don't really need 5 steps to be able to build the program, because some IDE, that's what you need to do, is to be able to set it up and then be able to put everything into project and build the program. So I normally use REPL.it for online compiler, or you can also use other online compiler. But when I demo the program, I usually use that because it's cloud. It stores all my program on the cloud. I can retrieve it, I can share it. It's a good, team environment where if you wanted to share your code or collaborate on code, that will also be useful. So I would use that type of platform. If you're not familiar with that, I can show you how to do it real quick. It's really easy. But if you prefer to use an IDE, that's really your choice. Okay, I'm not particular about the grading with that. As long as you can produce the program, I'm happy. So the course textbook is this book. I like to use very low cost book but that will deliver the content. I understand as a student, sometimes books can be very expensive. I know that now you can access ebook for a cheaper cost, but if you look at discrete structure textbook that the majority of the institution use, they're usually in the hundreds, or at least $100. So this book is more of like a workbook. It gives you the theory. It doesn't have the programming component like the normal discrete structure textbook, like Rosen's book or, other textbook. So I supplemented that. I write my own labs, and so the lab will be released in Canvas, so you can download the document and follow along. I think that this is an adequate book for the course, and I've been using this book for a while because it's free for you. You can click the link and download it, and you can find a PDF. It's not perfect, of course, but it has all the components that we need to cover. And, if there's anything missing, usually I supplement it with my notes and materials in addition to the book. Okay. And of course, you can have resources online. You can do additional research on your part if you like. So for procedure, activities, and grading is the next section. I organize everything in module as I mentioned. So every week we will complete a module, and the module just represent the unit. And there will be module for final exam and module for course project. So this semester I will release the course project sooner. Normally I wait until about week 10, which gives the students 6 weeks to complete the project. But my student survey always come back and they wanted the project sooner. So that kind of give you the preview on how you would set up your schedule and your work. Um, you can divide up your work timeline and be able to achieve the project. It will be broken into multiple parts. And the way I organize the project is I treat it like how I would manage a regular project, is that first you have to plan, then you write a program, test the program, and then you evaluate the program. So it has a project management component. So there will be multiple parts that will be required for the project. I do take late work. So if the student submit work that's about a week late, that's 10% deduction. I'm pretty lenient. If it's a day or two late, I don't usually penalize. I understand all of us have lives and family and obligations. But if you run into problem, like, you get sent out for work, or if you're busy with something, there's an emergency, please communicate with me and I'll work with you. So if it's a week late, just to be fair to all the students that have submitted it on time, that will be 10% deduction. 2 weeks late will be 20% deduction. 3 weeks late will be 30% deduction. I don't like to take anything above 3 weeks. It's just not fair for everyone. And I don't want student to turn in all their course assignments at the end of the course. So that way it just delayed the process for everyone, including myself. So for grading. So we wanted to make sure that we get our work completed. So in the class assignment and lab activities, I normally give you 2 days. So I cover and I walk you through the activities. So if you finish it at the end of the session, turn it in. That way you don't have to worry about it, and you can worry about your other classes like physics and calculus and things like that. But if you don't finish, you can have a couple of days to go through it and complete it. And I'm okay with that. So usually the assignments due date is a couple days later, and I like to wrap everything up in that week. And so that way I can grade and keep up with your grading in the following week. Okay. So for in-class assignments, we will do some of those together. I have taken courses throughout my time in school, and they just give you the book and they tell you, oh, solve this, right? And so when I told myself, if I become a faculty, I will never do that. So I normally walk the student through, and again, if you can't attend, please watch my video, and so that way you will be up to par with what you need to cover for the content. Course project. For your course project, as I mentioned, you will be given options. You do have the options to work in teams. And if you want to work by yourself, you can. But every single evaluation that I have received from online and regular classes, all my students mentioned that they should have worked in team. They should have completed the project sooner and not wait till the last minute. Sorry, my battery is running low. I've been teaching all day. So the course project will be released, and I think in this semester I will probably open it about week 6 or 7, kind of, give you some heads up, and you can decide on, whether you wanted to work in team or not. I might post a discussion board to talk about team, and so you can see who is in your class, and you can identify the individual. And I'm okay with you working by yourself. Again, it's going to be a lot of work. If you work in team, you can distribute the work and work together, but you will have to individually submit your project. I had tried doing the group submission, and you know, people forgetting to submit for their group, and it's just all chaotic. So preferably everybody submit all the parts, so that way we can be on the same uniform, and I can put in the comments, and I do give thorough feedback. Quizzes and exam, we will have a few quizzes in the class, and you know, they're every like 2-3 weeks or so. And before the quiz, you will have an assignment which prepare you for the quiz. So in this class, there's not a non-preparation moment. You will be prepared for the content and be able to, you know, take the quiz. And I do give multiple attempts for the quizzes. Final exam, I will have a final review, which covers all the things that we talk about during the semester. So if you complete the final review and if you're able to answer the questions, you're ready for the test. I do use Lockdown Browser for the final. So if you're using Chromebook, try to see if you can either borrow a laptop from school to take the test, or if you're able to utilize another system. It works on Mac OS and Windows OS. Unfortunately, it doesn't work on Chromebook right now, but you have to install that particular browser in order to take the test. And it locks you in, so that way you can't have other things open at the same time. That is just most of the time just standard procedure for test taking online. And quizzes are due at 11:59 on Sunday. So I will open it at the beginning of the week. You have the entire week to complete your quiz. And for final exam, again, I will also open it the beginning of the week, and then you have until the final due date. For our class, I believe it's going to be the Wednesday of June. I think it's the second week of June. So the final exam will close at 11:59 that day. I will put out reminders, and I will remind you in the class. For grading, I use standard scale. 90 to 100 is an A, 80 to 89 is a B, 70 to 79 is a C, 60 to 69 is a D, and 59 and below is the F. So for the categories, homework assignments usually review questions. They are 15%. Quizzes are 10% of your grade. In-class assignment and participation, including some attendance, that will be 20%. And if you miss attendance, you will have extra credit opportunity to make up some points in that. Lab activities, that will be 20%, project is 15%, and exam is 20%. Okay, so altogether we have 100% for our grade. Student code of conduct, I follow the college standards and policy. For the student that have issues, we normally submit a form that goes to student services. They counsel the student. That form goes into the student file. If depending on the case scenario, sometime if it's academic related, it will go to academic deans and also the vice president of academic for counseling and so forth. So for attendance and participation, since this is, you know, regular meet online, I will also look at your attendance as in your completion of tasks for the week, along with your attendance for Zoom. So if the student missed my class in 2 consecutive weeks, that's 4 total sessions or more, I reserve the right to drop the students. If the student decide to drop the class, make sure that you look at the timeline from WebAdvisor to avoid the W. Now, if the student just stopped showing up, you know, maybe 2/3 through the class, I would just give the student the grade that's earned in the class. And usually in those cases, the grade will be low. So CIS-7 is regularly offered. I teach it every semester. And I intend for you to get through the course successfully, understand the material, and you know, that way you can move on to the next classes and future classes in the university. Okay. For behavior issue, just respect each other. I respect you, So I expect the same thing from you. Avoid offensive feelings. If you have conflict with another student or other students, make sure that you address it with me. I will be stepping in, trying to address the conflict. We would avoid any kind of disruptions or anything that's demeaning to other people. For cheating policy, I understand that codes are available on, GitHub and other things. My former students, they probably post their code on there as I required GitHub before, and so forth. But do your own work, write your own program, answer your own questions in the assignments, because this is an educational journey. We don't want to use other people's material. Do not procrastinate and wait till the last minute and try to copy and paste the code. I do have software that checks for that. I read the code. That takes me a long time to grade the course. So I look at your program and such. I see some chat question. I don't use webcam for the part of lockdown browser. Some faculty, they do that, but I do use lockdown browser because, and if people are resourceful, they can still get away with different things, but it's supposed to measure, what your understanding of the concept. So I haven't used the webcam component only because some students, they don't have webcam, and they use an older laptop to finish the course and they don't have webcam. But, for this class, you don't need webcam. So as I mentioned, right, I had caught two individual in one of my programming class in the fall for their course project. They turn in part of the code that's very closely related. I addressed it. Yes, I could remove the student at the end of the course and drop the student. And so I ended up giving them 0 in that case because they were a good student throughout. They shared the code and they turn in the similar projects. So now in university, this is automatically termination. As I mentioned in my class earlier today, I taught a Python networking class, and I mentioned to them that I had a student that he went to UCR and his roommate turned in part of his program. The TA caught it and they terminated him from UCR. It's a serious thing at many levels, even at the community college level. So just like I said, do your own work, okay? Accessibility, if you need special accommodation, make sure that you contact DSPS. Normally my quiz is, the time that you get is pretty lengthy, even with the final exam. So I can add additional time for you if you submit special requests with DSPS. The accommodation will be responded. So they normally send me a form and then I would follow whatever that's recommended on that form. But even with that, if you still having issue, talk to me and then I'll make adjustment for you. Okay. For my contact information, if you work with me in the past, I respond email pretty quickly, but at the most within 24 hours. So the best way to get a hold of me is Canvas message or email. And if you like to talk to me in person, I do have Zoom office hours. Monday and Wednesday, it's 4:30 to 5:30 right before this class. I had a student meeting with me earlier. If you join the office hours, if there's another student there, you will have to be in the waiting room and I would put a message in there for you. But if there's no one, I will admit you. So it's admission process with Zoom. On Tuesday, you can meet with me on Tuesday and Thursday at 11 a.m. to 1 p.m. And the information for access is there. If you can't make these time, you can schedule an appointment, and I would look at my schedule and see I'm on different committees. I do different projects. But if it fits your schedule, I will let you know. If not, I will let you know when I'm available so we can meet. Friday is the best day if you want to make an appointment. I do have things going on Friday, but it's usually pretty open, or in the morning if you like. Okay, and I think that covers the syllabus. Do you have any question for me? Okay, so now let's get started with discrete. But check out the first module. You can also post a Q&A in there in case you have questions. It can be addressed by other students. If it's a private question, you can send me a message. There's a course plan there for you to look at the outline of the course, what activities you're going to be doing. I normally post all the assignments in each module, and I release one module per week. And if you need Office 365 like Microsoft Word, you can find out how to download it and be able to access it using your RCCD student account. Okay. Let's talk about week 1. So in this week, the to-do list tells us that we are going to be working with binary, hexadecimal. Since we don't have a second session this week, I will carry some of the material over to the next week so we can catch up. There are some tutorial videos I pull from YouTube. Some of them are good, very good. So you can check those out to be more clear on certain topic if you like. And please download your notes. Okay, I'll fix the video. I think I fixed it for my CIS-11 last night because they covered the same material in the first week. So I will edit the page and relink the videos for you. Yeah, when we transition to, because Canvas, they recently updated the interface from our part. Some of the embedded stuff it becomes unusable. So I have to go back and fix it. Thanks for letting me know. Okay, download the notes. So in this week, we're going to talk about numbers. If you attended CIS-11 last night, this is going to be very similar to what we talked about last night, same material. I just used a little bit different notes here. So in the computer, we know that it stores all data as 0 and 1s, right? At the machine level, it's all 0 and 1s, and a smallest unit of information is a bit, right? A byte is 8 bits. And so therefore, when we're looking at the unit for our storage in computing systems, we normally refer to something byte, right? Like megabytes, terabyte, etc. But bit stands for binary digits. And when we're looking at the binary system, it has only 2 numbers, either 0 or 1, and therefore it's known as a base 2. So often you would see that, textbook, they would write 0, 1, 0, 1, etc. in binary, and then you would see a 2, a small 2 for the subscript on the lower. Okay, so that just indicated that that is a binary system. Now, the counting number that you learn since you were young is a base 10, and this is what you use in calculus class, in algebra, in your daily life, right? We have, because it's incrementing 10, this is a base 10. So we go from 0 through 9, and then it repeats again. So when you get to 10, that becomes, it moves over 1 digit. So we increment by 10, 10, and then 11, and so forth to 19, and then we repeat again. So your counting number is considered a decimal system, okay? And that's base 10. So here, what that shows you is in the number system. So if it's a base 3, you would see that there's a base there's a subscript that says 3 or a base 5, right? The only other one that we would touch on is the octal, which is base 8. That's for the old legacy systems. And octal is not used anymore, so that's why we don't really have a lot of emphasis on it. But binary and hexadecimal is used. Hexadecimal is a base 16, and I will touch back on this, but hexadecimal is used in addresses, including memory address. So um, here it provides information about binary representation on page 2 of your notes. So as I said, the base 2 here shows that it is a binary. Now, when we're looking at a value, let's say a number 12 in decimal, when we introduce that value into the system. So for example, in your C++ program, you might have a variable called variable 1, like var1, and you initialize it as 12. You said var1 equal 12, right? So how is the computer storing that? It takes that decimal 12 value and convert it to 0 and 1s. So at the memory location, it's all 0 and 1s. It takes that 12, convert it to the binary value, and store it there. And in case you use that variable, let's say we pass that variable down the line, it just take that value that was stored in 0 and 1, right? And to be able to use it. And then when it outputs it, if you wanted to say cout, right? Value in variable 1 is, and then you bring down the variable name, all it is going to take that value that was stored in the memory location, convert it back, right? And then show you on screen, so it converts it, either Ascii or encoding system, show you on screen as 12. Okay, so human numbers is decimal, computer numbers is binary, right? So now we have to start thinking how the computer would think, so that way we can write appropriate instructions for the computer, right? Our programs, that's gonna be, including the processes. So if you understand that, right, that is really the computer science in general, is really knowing how to be able to interact with the computer, work with the computer, and be able to solve the problem, creating programs and telling the computer what to do to solve that problem. So now in this case, what it's showing is that we would start with the rightmost digit, the 1 to the right here, just like in decimal, right? You have the digit, the 10 digit, the 100 digit, the 1,000 digit, and we go on and on and on. And as you move to the left, you would see that we're incrementing, right? We're going higher. In the decimal, we're incrementing by 10, but in the binary, that's going to be 2 to the n. So if we start from the right, we refer to this as the least significant bit. That's the first bit. And if you see that as a 1, what happens is the signal will receive a full 5 volt. When it gets a 0, when it turns off, it drops to 0 volt. Okay. So and we utilize this to really store our data, right? Whether you put it on your flash drive or if it's on RAM when you're playing a game, all of this is happening. So now, as you see on the right here, that's the least significant because it's 2 to the 0. Multiply it by 1. That's going to give you 1 because 2 to the 0 is 1 and 1 times 1 is 1. And as we move left, we're going to do a plus. So as we move left, we're going to have 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, 2 to the fifth. And the equivalence of this in decimal is 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, and so on. Okay, so the least significant bit happens to be the rightmost bit. In this one, the most significant bit is this guy in the front, the leftmost bit, okay? And we know that because the decimal equivalence value is going to be 2 to the n, so in this case, that will be 2 to the 5th, okay? So when they add this together, we would have the decimal equivalence of 37. So I'm going to pause here. I'm going to switch to the assignment. And so I can walk you through the process so you can understand it a little bit more. Actually, I'm going to open this. Okay. So now we're going to do the conversion. Okay, the example that's given you there. So let's talk about the example first. So let's say that you have the decimal value 14. This is base 10. And you need to convert it to 0 and 1s, which is base 2. So the approach that's easiest is to, when you're going from decimal to binary, the easiest approach is to do a subtraction. Okay. So for the scale down here, it shows you 2 to the n, right? Starting with the least significant bit on the right-hand side, okay? The decimal equivalence of this is its multiple of 2. So we start with 1. We always start with 1 on the most right because 2 to the 0, that's 1. Then you multiply that 1 by 2, move it over to the next digit. That's going to be 2. 2 times 2 gives you 4. 4 times 2 gives you 8. 8 times 2, 16. 16 times 2 is 32, and so on. Okay. And this scale is the same always when we're doing the conversion with decimal and binary. Okay. So if you're given a decimal number 14, how is the computer storing that, right? It needs to convert it. So for human, we can use the subtraction method. So let's say my analogy for this is, let's say you have $14 in your pocket and you go to a store and you walk down this aisle and all the items, right, starting with the beginning of the aisle to the end of the aisle, it's going to increment by $2. Okay. So from my perspective, I'm just going to pick the one that I can afford the most, right? So $14, I can say, okay, which item I can select to be able to buy under $14. So with 14, if we're looking at the scale, we're going to say, oh, 8 is going to be the number I can subtract 14 with and not going into the negative. Okay. 16 is too big. We can't subtract 16. Like if I have $14, I cannot buy something that's $16. No, right? So we're going to start with 8. So I'm going to take 14, subtract 8. And when you subtract that number, you're going to put a 1 on top. There's a signal, right? 5 volts. 1, it turns on. So when I subtract 8, I have 6 left. I'm not done. I have to keep going. So I have $6 left. So now I can subtract 4. So 6 subtract 4, I have a 2 left. Okay. 2, I subtract another 2, right here, and I get a 0 left. So when you're going from decimal to binary, you simply just use the subtraction method, or you can do a division method. Okay. But in this one, it shows you the subtraction method. So once you have 0 left, you're done. Okay. So you're going to subtract until you cannot subtract anymore when you get to 0. Okay. Let's do one together. Let's do the next one, 309. Okay. So for A, convert 309, which is decimal, into binary. So you look at this line, this scale, you said, what is the highest number I can subtract from? That's going to be 256. Okay, so 309 minus 256 is going to be 53. Okay. If you subtract it, you put a 1 on top. Okay. So once we subtract 256, we have 53. I cannot subtract 128 with what's left, right? Because I have 53 left. I cannot subtract 128, too large. So 0. I cannot subtract 64. No, too large. 0. But when I get to 32, I can subtract 32. So I would take 53, subtract 32. And when I subtract it, I got to put a 1 on top. Don't forget, because that changes the value if you miss a 1. Okay. So when I subtract 32, I have 21. Okay. So at this point, I have 21 left. I can go again. 21 subtract 16 because 16 is under 21. So we're going to go ahead and take 21 minus 16. Put a 1 on top. We have 5 left. Then 5, we cannot subtract 8. 8 is higher, so no, put a 0. But 5, we can subtract 4. So I subtract 4, I put a 1 on top. That means I have 1 left. And then we skip 2. 2 is higher than 1. 1 minus 1. Since we subtract 1, that's going to be 0 left. Okay, so if you subtract that number on the scale, you got to put the binary on top because that bit is turned on. Okay. And when you write out your answer, you simply type out the 0 and 1s. So that means that we would go 1 0 0 1 1 0 1 0 1.
Question.
Yeah.
You want us to show all that work right there where it's like 309 minus 256? You want us to show all that, or just or can we just use the chart up here? Oh.
You can use the chart. You don't have to. I do that so you can follow.
Okay, thank you.
Yeah. And if you wanted to be exact, we would put the little base number. So we said that's a decimal and this is a base 2. Okay. I'm not a math faculty. Math faculty would make you write out everything, right? If you can do it in your head, more power to you, right? I do not allow programmer calculator mode on the final, but you will have the scientific calculator available on Lockdown browser. So talking about calculator, right? If you never use the programmer mode, you open up the calculator, and I'm using Windows 10 to demo this. So just to, and Mac has the calculator. Even your phone, you can activate the calculator, but not all operating systems support the programmer mode of this. So on Windows, you simply click this and you can change this. I don't know if you know if your math instructor show you this, but you can do graphing. You can do scientific for, used for calculus classes or other classes, trigonometry. But for us, we can use the programmer mode. So how do you enter it? So if earlier, remember we did 309, right? So first you select the number system that you're using, decimal, and then you type it in 309. And you notice that it gives you the binary here. If you want to see the result, click on it. Okay. Now the octal value is here and the hex value is here. Well, now you know, right? Now you don't have to buy a graphing calculator. I went to UCR, so they didn't let us use any graphing calculator, taking calculus classes there. When I entered UCR, I had to take one CEF because I took calculus in high school, And so everything you graph by hand, I don't know if they still do that now, but some math faculty can be hardcore, right? Me, technology, if you can use it, that's great, right? Will we ever do this manually in the field? No, right? But you have to understand how it's done, because the programmer create calculators, right? They create these tools. So you as programmer, you have to understand the concept, so that way you can solve bigger problem. Maybe you can create a better tool. So yes, you can use your calculator to check. Okay, the next one, I'll help you with this one too. So we need to convert 94 to binary, right? You probably saw my answer there. So I'm going to walk you through it. So we're going to start with the decimal 94. We cannot subtract these guys right here in the front. 256 is too big. 128 is too big. So yes, you can technically put in the 0 there, right? But if you enter the value into the calculator, you know that it omits the 0. It's off. It's null, nothing, right? We don't need to put the 0, but if it helps you, you can put the 0. Okay. And so for the next one that we can subtract is 64. 94 minus 64 gives us 30. So we subtract it. I'll highlight it. And then we put a 1 on top. We're left with 30. We have to keep going. 32 is too large, so we can put a 0 on top. And then we would move to the next number to its right. So we would take 30, subtract 16. We would put a 1 on top as we subtract it. And then we're left with 14. And we keep going. So if you're fast with just arithmetic, you know that it's 8, 4, 2. So 16 subtract 8, you should have, I'm sorry, 14 subtract 8, I apologize. 14 subtract 8, because we have 14 left from the last one. Then we keep going. The problem with this is, let me move it to the next page so you can see all together, okay? Okay, so 14 subtract 8, you have a 6 left, 6 subtract 4, and then you should have a 2 left, and then 2 subtract 2, and you have 0 left. So your binary is 1011110 for 94 in decimal. For my CIS-11 last night, since we have to cover the assembly part, talking about programming language and things like that, I didn't touch on the division method, so I will cover that in discrete. And you can look at the notes. I think I provided their notes with it too. So, okay. Any question on B? Okay, so let's talk about the division method, okay, which is number 2. I'm going to do the example. So if you go down on the notes, so here it shows you on how to do the conversion with addition and subtraction. We covered that. Here's the using the division method. This is on page 3 of the notes. So you start with, you're given a decimal, and I wrote down the step here for you. So we're dividing by 2 because we're converting a base 10 to a base 2, okay? Then what we want to do is when you divide it and you don't have any kind of remainder, okay? And using division method in conversion of number system, remainder is important. So, if you're familiar with programming more, right? Mod is what we're using now. We're looking at the remainder or not. So if you have a remainder, then it's, it's going to be a 1. If there's no remainder, it's a 0. Okay. So if you divide it and it divides evenly, If it's a 0, if there's no remainder, that's a 0. If there's a remainder, you put a 1. Okay? And then when you're finished, you're going to go from bottom up for left to right. So we're going to start with 152 as our example. We're going to take 152, we're going to divide it by 2. That, since it's an even number, it divides evenly. It gives you 76 as a quotient. We put a 0. And then you take the 76 from the quotient from the previous one here, and you divide it by 2 again, you get 38 as a quotient. Again, it's an even number, so 0. Take 38 divided by 2, you get a 19 as a quotient. Again, 38 is an even number, it's a 0. 19 divided by 2, you get a 1 remainder because that will be a 9 as a quotient with a 1 left over. That's a 1. So when you have a remainder, you put a 1. And then you take 9 divided by 2, that gives you 4 as a quotient with 1 remainder. Again, 1. And you keep going. So we're here at 4. 4 divided by 2 is going to be 2. No remainder. 2 divided by 2 gives you 1. No remainder again because it's an even quotient. Then 1 divided by 2. We're not done here. A lot of the students make mistake. They stop right here, which is we're missing a digit. Okay. So when you still have a quotient until it gets to 0 is where you stop. So 1 divided by 2 is a 0 with a 1 remainder. So that's a 1. Since it's since it's an even number, the least significant bit is going to be 0. So we're going to go, the left is going to be from the bottom, right? That's the most significant bit. So if you write from left to right, because that's how we type, right? That's how we write. You're going to go from bottom up. That's why I put the arrow there for you. So you're going to start with the 1, which is going to be from the bottom here. That's the first one there. Okay. So any question with the division method? Let's try it. Okay. So let's try it with the division method so you know how to do it, right? Here I put down the steps and the example for you, but we can do 185 divided by 2. That's going to give you what? 97, right? 18 divided by 2, or I'm sorry, 92 with the remainder. That's going to be 1. Okay. And then 92 divided by 2, that's going to be 46 with no remainder. And then 46 divided by 2, that's going to be 23. Again, no remainder. And then 23 divided by 2, that's going to be 11 with the 1 remainder. 11 divided by 2, that's going to be 5 with 1 remainder. 5 divided by 2, that's going to be 2 with the 1 remainder. And then 2 divided by 2 is 1 with the 0 remainder. 1 divided by 2 is a 0 with the 1 remainder. And so our value is, remember, bottom up, left to right. So this one goes first. I'm going to highlight that so you know 1. And then it's going to go 0, 1, 1, 1, 0, 0, 1. Since it's an odd number, the least significant bit on the right is always on because it's 185. Okay.
So I had a question.
Yes, Sarah.
So no matter what, whatever the remainder is, it would always be a 1 if there's a remainder of an odd number?
Yeah, because when you're dividing by 2, it's always going to have a 1 remainder.
Okay.
Yeah, so if it doesn't have a remainder, it's a 0. And whichever method you use, whether you use the subtraction method we talked about earlier or this method, whichever is easier for you, you can use. Okay.
Thank you.
Yep. But you know, if you don't have a calculator, this is what you do, right? And division sometimes is harder when we get a large number. You just have to know how to do. I learned long division. I think they teach you a different math method now for how to handle division. But you know, when we convert hex, you're gonna see that we're gonna use division method too. Okay. Any question? Okay, so this is how the division method is used. You can also practice it, right? And sorry, that cuts off because I moved my stuff down further. Now, ultimately, when we're looking at subtraction, I'm going to talk about this in my assembly class. It's when you divide, you use subtraction opcode. You subtract it multiple times. When you multiply, you just add it multiple times. The computer, it just adds, right? When you use arithmetic like 2 plus 2, it adds 2. 2 subtract 2, it adds 2, -2 to the value. So you add the complements of it. Okay. And the purpose of the computer is that we use it for what? We use it to calculate arithmetic originally. And then now there are other things that we use it with, but originally it was designed to calculate. It's a calculator. Okay. All right. So let's talk about going backwards. We're going to go from binary back to decimal. We already talked about decimal to binary using subtraction and division. Now we're going to use addition method to go in reverse. Okay. So for number 3, it says use the binary to decimal conversion placeholder, convert the unsigned binary to decimal. So when you see the word unsigned, just know that I refer to positive value. In programming and in computing, we use sign and unsigned. We don't say positive and negative, right? So for the unsigned, that just means that it's positive. So when you have these 0s and 1s, all you do is you put them into this scale. Remember the placeholder scale that we saw earlier when we did subtraction? And if you want it to be thorough, you should start with the least significant bit, because when you have a longer value in binary, it can get confusing, right? You mix them up in different places and it changes the output. So we would start with the 0. So put them into your placeholder scale like this. Okay. And then you're going to add up only the decimal equivalent that's going to have the 1. Okay. In that scale. So we're going to add 2 plus 4 plus 16 plus 32. We do not add the value that has the 0 on top, because remember earlier we didn't subtract it because it was too large, right? So you only going to add the value that has the 1, that has the bit turned on. So when we add all of these together, 32 plus 16 plus 4 plus 2, we get a 54. Okay. So when you're going from binary to decimal, you would do the addition method. When you're going from decimal to binary, you subtract or divide. Okay. Any question with this? Number 3 example. Let's do C together.
I was gonna ask, so in this case, if it's addition, you said you can either use division or subtraction to get your binary numbers?
Yes.
Okay.
Yeah, either method, as I mentioned earlier, if you subtract, I prefer subtraction because it's easy. I can do it in my head, right? And division, if it's a small value, I can do it in my head. Otherwise, I have to write it out, right? So yeah, you can do subtraction or division for decimal to binary. And then when you go in reverse, you can use addition. You can apply the multiplication. There are some sources that shows that. It's just you multiply it to the nth value, which is multiplied by 2. So, okay.
Thank you.
Yep. So let's do C together. So what I do is I take the binary value and I put it on top of the scale. And from the right, if you don't remember, if you know that the least significant bit is always going to be that 1, right? One in decimal there. Then you just multiply it by 2 as you go along. 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, and so on. Okay. Then you take the binary value and you start with the least significant bit and you go left and you put them on top of the scale. Then you're going to add up the decimal equivalents of the bits that are turned on, the one that has the 1. Okay, so I need to add the 1, the 2, the 8, and the 32. So that means that once I add it all together, I should have 43. I was just checking my math in my head there, 43. Okay. Any question with C? And for my 15 years of teaching, I started out teaching computer repair for electricians. So I had to talk to them about this too, because, you know, in going from analog into digital, they have to understand, right, some of the concept. And with the computing concept, we go into binary. And so I found that this technique is the easiest for most students to understand. Okay. All right. That's the addition method. Okay. The next one, I had started this one last semester. I saved the file. So you just simply take this value that's given for D, and then you put it onto the table of the scale. And then after that, the next step is to add up the decimal equivalent that has the 1s on top. You're going to skip 32 and 16 because those have the 0. Those bits are turned off. Okay, and then you would have the decimal value, the output, after it's converted, after you added those together. Questions?
So it would be 79.
64, 64, 72. Wait, hold on. 74. Yep, you're right.
Okay.
Very good. All right. Are we ready to add binaries? I see a chat. Okay, good. I'm glad. Okay. For me, if I don't understand something at the very basic level, I cannot go to the higher level. So I want to make sure that you understand before you get to the next level. All right, good. Okay, so let's talk about addition. So like I said earlier, the computer adds, right? And you know, we would take a look at how, let's say that you know, simple things like you learn addition in grade school and elementary school. And they said 2 plus 2, and they teach you that, you know, you count with your fingers, and you said 2 plus 2 is 4. Well, the computer takes everything and puts it in binary, and it needs to operate arithmetic with it, right? Because originally, like I said, they design it for arithmetic purposes, and now we scale out for other type of task like gaming and things like that. But at the simplest level, we need to add. So the add rule is that if we do 0 plus 0 is 0, of course. If it's off and off, it's off. 1 plus a 0 is a 1. So when you have a bit that's on, add it with a 0 that's on. When you do 0 plus 1, it is a 1, same as that. And then when you do a 1 plus 1, that's a 0 with the carry. This is not 10, it's a 0. And then it takes that 1 and it moves it over to the next left digit. Okay. So it's a 1 and a 0. Okay. It's very much like this. You take a 5 and you add a 5, right? You have a 10. So you take a 0 and then you put the 1, the 10. It's now moving into the 10 digit. If you take 56, add it with 56, you have, you know, 100 something. So you move again to the leftmost, the next left digit. So the extra digit generates a carry. That's what we carry over to the next column, right? And it's higher in significance in that byte. So what we will do is we will look at this example. And I took the snapshot from one of the textbook because it does a really good illustration with this. Okay. So when we do this, we would have 0 plus 1, that gives you a 1. Because the rule said 0 plus 1 is going to yield a 1. A 0 plus 1 is going to yield a 1 again. But when we get to here, a 1 plus a 1, it's going to be 0 with the carry 1. It's going to bring that 1 to the next column on the left. Now, the tricky part is to handle it 2 row at a time, okay? So first, what we're going to do is we're going to operate the addition at the top level, get a result, and then we're going to move to add the next part. So a 1 plus a 0 is a 1, okay? A 1 plus a 0 gives you a 1, okay? And then the rest is 0. So we finish out the carry there, okay? So what I'm going to do is I'm going to illustrate number 4A using whiteboard on Zoom. I hope I enable it for this particular. Let me stop sharing. I'm going to switch it real quick, okay? Actually, hold on. Let me copy the question so I don't flip back and forth. And then we're going to go into whiteboard. So now, and please forgive my chicken scratch because I'm using my hand on my touch screen. So I don't have the stylus for this laptop. Okay. So this is our problem that's given to us, right? And so I'm going to rewrite it. Actually, can I draw it into here? Okay, I'll just draw it into there so I don't rewrite it. Okay, so now you're going to start with the right. Okay, a 1 plus a 1 on the right hand side, that's going to give you a 0 with the carry. Okay, now what we're going to do is we are going to handle the top 2 first. Okay, so a 1 plus a 0 is going to give you a 1. Ooh, Okay, let's try that again. So a 1 plus a 0 is going to give you a 1. Okay. And a 1 plus a 1 is going to give you a 0 with the carry. Okay. I normally put the 1. Hold on. Right there. So that way we don't confuse ourselves with that. Okay. So we had a carry over to the third column now. Now let me swap pen. Let's do a 1 plus a 1. We're going to handle this. Okay. That's going to be 0 with the carry. A 0 with the 1 is a 1. Okay. A 1 plus a 1 is a 0 again with the carry. And then a 0 with the 0 is a 0. And then now what we're going to do is a 1 with the 0 is a 1. So now we're going to handle these guys. That's a 1. And a 1 with the 1 is a 0 with the carry. And then we're going to handle the top 2 again, just like what you've done in the other one. A 1 with the 1 is a 0 with the carry. A 0 with the 0 is a 0. A 1 with the 0 is a 1. A 1 with the 1 is a 0 with the carry. A 1 with the 1 is a 0 with the carry. A 0 with the 0 is a 0. This one just drops down. So your answer is 1 0 0 0 0. There's 4 0 5 0 1 0 0. Okay. So the best technique in addition is when you have a carry, you bring that carry to the next left, and then you're going to handle the carry with the top number, get the result, that temporary result, then take that result and add it to the lower number, and you would have the output for that column and then move over again. And sometimes you do have multiple carries, and so that way you can see in this illustration. Okay. Any question? Now for the class, I'm fine with you handwriting stuff and take a picture and submit it or scan it. If you can't type it out, that's fine. I'll take it. As long as I can read it to grade, I'm fine with it. Okay. Are we okay with this?
Sounds good. Yeah.
All right. Let's see the chat. All right. Okay. So let's switch back to our question. So please complete B. Okay. So I would start with the right, carry it, and if it continues to carry, and you can use your calculator to check. You can type in the 0 and 1 added and make sure that you have the right answer. Or another way is to convert it to decimal, add the decimal, and see if your sum in binary is equivalent to the decimal. That way you can practice at the same time. That's fine. Okay. Then we move to subtraction. With the subtraction rule,
Professor,
yes.
I still think you're on another slide.
Oh yeah, I'm sorry. It needs to stop. I keep forgetting that the whiteboard doesn't give me the screen. There you go. Thank you. All right, let's talk about subtraction rule, which now I'm in your assignments. So right before number 5, we see that 0 subtract 0 is 0. 1 subtract 1 is a 0. 1 subtract 0 is a 1. Okay. When you take a 0, subtract a 1, you have a 1, but you borrow from the left. Okay. You borrow from the left. So let me see. I think I put an example on your notes. There's the addition. There's the subtraction. So I'm going to look at this is the notes now. We're going to look at the example first before we attempt. Okay. Recall that the subtraction method is there. Okay. So if we start, so this is the decimal equivalent. What we start, this is our binary. We're going to take this binary and we're going to subtract this binary. And so we're going to start from the right. A 1 minus a 1, that's a 0. Easy. Okay. So put a 0 because subtract, fine. 0 subtract a 1, we have a 1 with a borrow. Okay. We borrow 1. Okay. And then you're going to take that 1, you subtract the 0, which gives you a 1, and 1, 1 subtract the 0. Wait, I'm sorry. Oh, they put a 0 right here. 1 subtract a 1 is a 0. 0 subtract a 1 is a 1 with a borrow 1. Okay. Yeah, put the 0 there is confusing. So again, we borrow a 1 because 0 is less than 1. Okay. You're going to take that 1, just like what you did with the add. Same thing. You're going to take that 1 and you're going to take that 1, subtract the 1, which gives you a 0. And then take that 0, subtract the next row, the next number lower, which gives you a 1 with the 1 borrow. And handle 2 numbers at a time like what we've done before. Okay. All right. So this is the example. I'm going to illustrate the assignment. So this is 5A. Let me stop share and go to whiteboard again. Okay, let's clear all drawings. Okay, let's line it up a little better there. Okay, so now we are going to I tried using my mouse last night. It didn't work out too good. So, all right, let's start with the most right. Okay, we have 0 minus 1. We know that this is a 1 with a borrow, right? Then just like what we've done before, we are going to handle the top 2 first. Get the result, take the result and handle the bottom number. So 1 minus a 1 is a 0. Okay. 0 minus a 0 is a 0. Okay. Now, done with the borrow for at that point, a 1 minus a 1 is a 0. A 1 minus a 0 is a, what is it? One, right?
Yes.
Okay. Sorry. And then a 1 here, a 1 minus a 0 is a 1. A 0 minus a 1, now we're borrowing again. So it's a 0, I'm sorry, with the 1. Wait, did I get it right on the first one? Yeah, that's right. Okay, sorry. It's been a long day. Okay, a 1 with the borrow. And then a 1 minus a 1, again, we're going to handle the top part is a 0. okay? And a 0 minus a 1 is a 1. Again, we're going to borrow, okay? And then you just take that 1 and then you're going to bring it down and you're going to have that. Now, this brings up a great point because the computer, remember, the only difference between the signed and unsigned is how it used the bits and the location of the bits, okay? Well, how does it know that this is a negative number or a signed number, okay? What it's gonna do is, let's say that this is technically the value right here, okay? The output from the subtraction. All the rest of the bit to the left, it's gonna put the ones in the front, and this just represent that it's a sign, which is a negative, okay? Because your output is only the value right here. So when you're looking at some, you know, let's say the value that's only gonna come up to 5 bits, and when it represents that in a byte, it's going to take the three bits in the front and it's going to fill in the 1. It's going to turn off those signal to represent a negative number. Now we see this in the calculator, okay? That means, so let's say that I'm going to have a decimal number. Let's say that I have a 3. That's easy. We can quickly convert binary. Subtract a 6. I know in my head from learning arithmetic that this should give me a -3 in decimal, right? Okay. You see how this is shown. Oh, I need to stop share. 1 second. Okay. So again, let's do that again. We have a decimal number, a 3, subtract a 6. We know that it's a -3, okay? So in decimal, it's a -3, but look at how it represents that in binary, okay? Because the 3 is only here. 1, right? Actually, the -3 is the complement of the 3. We'll get into 2 complement later on, so you know how the negative number is represented. But this is how it's shown. It's gonna fill in all the rest in ones, and I'm in the quad word, which is 64-bit, and you can size it down. So when we're looking at a byte, it's going to take the rest of the bits here and put in the 1 to represent the negative sign or the sign value. Okay. Any question? Okay, so now you can see how that's like. You can always change the length of that word, double word. And this is Microsoft, so it's treated the word as 16-bit. And for my assembly students, they know they're going to learn about word sizes and such. Okay. All right. So now we already work on the subtraction. You can practice doing B. You don't have to turn in your assignment today. You can work on it in, today, tomorrow, and then turn it in for the due date. So start with the right, subtract when it borrows, carry it to the next column, handle 2 numbers at a time. Okay. All right. Any question? Okay, so I'm going to lecture on some of the other stuff since we didn't have the first day. I wanted to touch on hexadecimal and things like that. So going into next week, you will be prepared. I have a chat question. Okay. B is hex value. And then the output, yeah, the output is 0, 1, the 0 and the 1 is in binary. So if you, for the answer, you can just leave it in binary. B is in hexadecimal. Okay, so let's talk about multiplication. So for the multiplication, very similar to how we learned to multiply in decimal. Okay, you're gonna start with the right and looking at the rule first. 0 times 0 is 0. 1 times 0 is 0. 0 times 1 is 0. Just like in decimal, anytime you time a 0, it's a 0. And then 1 times 1 is 1. Very much like decimal. It's very easy. So we would start with 1 times 0 is a 0. 1 times 0. So I'm going to go from the lower right here, and I'm going to go apply it to all the digits from the top to the top. Okay, so 1 times 0 is a 0. 1 times 0 is a 0. 1 times 1 is a 1. 1 times 0 is a 0. Second line now, second number. 1 times 0 is a 0. 1 times 1 is a 1. And then you add them. Just like, don't forget, right? We just learned how to add. So 0, technically when it's empty like this, it's just a 0. So 0 here, 0 plus a 0 is a 0. 1 plus 0 is a 1. And 1 plus a 0 is a 1. Okay. So this is the output when we multiplied this. Now on the last part is, it talks about a byte. And a byte is 8 bits with the leading zeros allowed. So there are 256 different bytes that represents the integers from 0 to 255. 0 means all the bits are off, and 255 is all the bits are on. And if you are good at networking, as I talked to my student earlier today, you often see something like this. 255.255.255 as subnet mask.0. So in this is version 4 IP. This is what they use to identify what part of the network that system is communicating from. It's kind of like your area code or your zip code for your mail and area code for your phone. So in the appliances, the network appliances, it has a processor, it has RAM. So the processor, what it does is it says, oh, the bits are on here, the bits are on here, the bits are on here, the bits is off here. That means it's coming from this part of the network. Okay. And so you do see some binary applying into like networking concept and addresses and stuff for the version 4, and then they use hexadecimal for version 6 addresses. Just side note in case you're curious. But you would see how it's represented, and ultimately the appliances is programmed by developer, right? Created by engineer, programmed by developer. And sometime when you work with hardware company like Cisco or Fortinet, stuff like that, you build these appliances, you engineer these appliances, but you have to instruct it what to do. And yes, it is a computer. It has processor, it has RAM, it stores, tables and things like that. So that's what you see. And your wireless router, it uses this thing to really also, this schematic to really also identify your network. And when you ping and stuff like that, you will see your addresses either in version 6 or version 4. Okay. A word is a basic unit storage whose size depends on the processor. It says computer, but this should be processor architecture. And assembly class CIS-7 addresses that, how to write instruction for processor programming. So the words are commonly composed of 4 or 8 bytes. So when you're referring to like 64-bit this, 32-bit that, like applications, that is really respectively looking at what is the composition of the size. Okay, so 4 bytes equal to 32 bits, and so on. So as you know, if you're looking at the history of computing, earlier our systems definitely smaller in how we were looking at storage and the data that could be processed, right? Like 8 bits, 16 bits. And then we scale out to more modern system where we would look at 32-bit and 64-bit. And, you know, now we have a lot of transitions into the 64-bit because our processor is able to utilize 64 bits. Older system only able to process, you know, smaller word size, 8 bits or 16 bits. And we were at the 16-bit for a bit before we transitioned to 32 and so forth. Okay. I know that you probably have learned to program char, right? You know, use char type using, you know, your alphabet in English, A, B, C, D, E, F, G, along with the symbol. Something like you might use string and then be able to pull different characters from there, or looking at the ASCII decimal equivalents of an A, a B, a C, a D. And most of the C++ compiler will handle some of the conversion for you. So when we're looking at the speaking language or the text that humans see, it still needs to be converted to numerical values, right? And when, you know, I don't know if your teacher has showed you, if you ever look at Ascii Table. Okay. And in this class, we will work with this when we're looking at encryption. So when we're looking at Ascii Table like this, okay, you would see that it has, oh, these websites is never ending. Okay, it would have the decimal and the hex equivalents. Okay, so now you understand. So when I have a 0, that's a 0. For the hex, right, 0 through 9 is the same as decimal 0 through 9. But when we have a decimal that's 10, that's going to be an A in hexadecimal system. And 11 is B, 12 is C, 13 is D, 14 is E, 15 is F. And then 16, it changes, okay? Now, if you're looking at character, as I was talking about character earlier, right? A capital A, the decimal equivalent of that is 65. The hex is 41. The octal is 101. So for HTML, we would use this. Now the lowercase a is 97, right? So that's how the system is going to be able to distinguish between different characters by using numbers that's assigned or in the encoding system. Okay. So going back to our notes, so now you can see, so it touches on that. And then Unicode is the international standard for encoding for all characters and languages, which is higher, right? Because ASCII, once you hit 127, it's done. That's the limit, okay? And we're gonna do a lab in this class, right? And you're gonna see when we reach above the value, let's say 128 or 129, the compiler cannot output anything because we're trying to convert it back to a character that's unknown, okay? So if we're using the ASCII encoding, it's only going to go from 0 to 127. It ends there. And then it talks about ISO. So this is for Latin 1 and Mac Roman, which goes above 127. So in the case where if you're looking at, you know, languages that would have accent letters, right? When you type in text that will have accent letters and special characters, we would we would need to implement a different encoding outside of ASCII because it's limited to only the symbols and the characters that's allowed between 0 to 127. And then here it talks about UTF and the encoding with unicoding characters, which is wider. So in hexadecimal, as you saw that on the table, 0 through 9 in decimal is the same as hexadecimal 0 through 9. But when we get to decimal that's 10, that's going to be A in hexadecimal. 11 is B, 12 is C, 13 is D, 14 is E, and 15 is F. And that completes the 16 value in hexadecimal. It is a 16 base number system. And when do you see hexadecimal? You see hexadecimal in IP version 6 addresses. So if you ever do IP config on your computer in command line, right, or IF config on, terminals in Linux or Mac, you would see the addresses. It's going to say network addresses, right? Or you would see in memory address. Memory addresses use hexadecimal. I told my assembly class last night that, we would refer to that with an X. It's all that is that just indicate that it's an address, X, and a value in hex. Okay. It could be A4 to etc. Okay. And hexadecimal is also used in the physical address of your network interface card, which we call a MAC address or a media access card, right? So if you connect to the network, you use the Ethernet port, that card is ingrained with an address that identifies that particular Ethernet adapter. If you use Wi-Fi, it also has an ID or a physical address. So hex is used quite a bit. And then if you program HTML, right, you use your color wheel, like you wanted to make different shades of blue and green and red and yellow, then you would use the hex value there. Okay, so a lot of use in that. So, all right, let's touch on the conversions. Okay, so let's say that we need to convert hexadecimal back to decimal. Okay, so we're given a hexadecimal value A2, and this is a base 16, so we know it's a hex. And how do you convert it to decimal? Well, decimal is base 10 and hex is base 16. So what you do is you would write it out using 16 to the nth value, starting from the right with the n to the 0. Okay, n is 0. So you're going to take the least significant value, which is 2 here on the most right, and you're going to multiply it by 16 to the power of 0. So anything to the power of 0 is 1. So 2 times 1 is going to give you 2. Okay, then you're going to add it. This is the multiplication method. Okay, the A is 10 in decimal. So you're going to take the 10 and you're going to multiply it by 16 to the power of 1. So in the case, if I have more digits, we would just raise it by 1 plus power. Okay, so let's say if I have another digit here, we will take that value and multiply it by 16 to the 3rd and then 16 to the 4th for the next one and so on and so on. So when you add this together, you get 162 in decimal. Okay. Here's another example using multiplication method for conversion from hexadecimal to decimal. Okay. And as you see, you have 1, 2, 3, 4, 5, 6, right? There's 6 digits here for this hex. So therefore we would just start from 0 and we would increment our exponent by 1 as we move to the next digit when we multiply it by 16 to the power of 1 plus when we move to the left. Okay, that's fine. Okay, so I think for our assignment I ended with 5, but I'm lecturing so that way when we get to next week we would be able to address some of the questions because we're going to handle truth table and hexadecimal conversion and octal next week. Okay, so this note shows you how to convert hexadecimal to decimal using multiplication method, and I put down that. Also, the way that we can look at it in binary is that each of the hex digit is 4 bits. Okay, it's a nibble, which is half of a byte. So each of the hex digit is 4 bits. And so you can also convert hexadecimal to binary. Okay. For the byte, it would represent 2 hex digits. A byte represents 2 hex digits, as each hex digit is 4 bits. So when you're looking at A2, that is a byte, right? Because there's 4 bits for the A and 4 bits for the 2. Together, that's a byte. Okay. And then when you have 4 digits in hexadecimal, that will be a word or 16 bits. Okay. So, and here it mentioned that for a 32-bit word, which modern system, the newer processor uses word size that's much bigger, like 32-bit, and that would include 8 hex digits, or equivalent to 8 hex digit. Okay, so let's talk about hexadecimal conversion. Well, we touched on this already. You saw the multiplication method, so I put in some additional notes for you there. You can practice them. Okay. Now, if we go into hexadecimal to binary conversion, we have this binary and we need to convert it to a hexadecimal. So what you do is you take the D, okay? Let me type out the notes. So D is equal to what is in decimal, right? A is 10, 11 is B, right? 12 is C, and D is what? 10, 11, 12, 13, okay? Then 13 representation in binary, then you can convert it using subtractions. So we know that it's going to be 8, 4, and 1. Okay, so 1, 1, 0, 1. And if we take the 3 represented in 4 bits, we have 3 is equal to 1, so 0, 0, 1, 1. Okay, so together when we write D3 like this, it's D3 in hexadecimal is equal to 1101. Sorry, I have it on the subscript still. And then 0011. Okay. So to approach this type of problem, you first start with taking each of the hexadecimal and using 4 bits in binary to represent it. Okay. So if I have longer hexadecimal value, each of the digit represent 4 bits. So the 5 is this one right here. The E is this one right here. The 9 is this one right here. And the F is this one right here. And F, everything is on for the 4 bits. So going back to our calculator, okay, remember we did 3, subtract 6, we have a -3. Look at the hex value. It uses the F to represent the sign or the negative value because F means that all the ones are on, which indicates this, isn't it? Okay. So when you see the sign value in hexadecimal, you would see that the F will be in the front. And in binary, the 1 is in the front. Okay, to show that it's a negative sign. Because when it's F, it all the bits are 1. Okay, and you can convert it if you wanted to test it, right? So if you have 15, what adds up to be 15? 1, 2, 4, and 8. So all of those bits are on. Okay. Any question? I know that we finish out with the assignments. I'm lecturing so you can understand this, and when we do assignments next week, we can revisit it, but we would be able to get through it. Okay. Okay, so let's talk about octal. I do have like about 12 minutes left, so I want to use the time effectively. Octal system is legacy. This was used for 6 bits, 6-bit byte, and 2 digital octal number. So it's older, but I want to show you how you can convert it. Okay, so octal is a base 8. And you would see the subscript of 8 being used. Okay, 273 base 8. We would use the same technique that we would use in hexadecimal, but instead of multiplying by 16 to the power of something, when we're going from octal to decimal, we simply multiply it by 8 to the power of n, starting with the 0 from the most right and incrementing the exponent by 1 going left. Okay, so I would have the 3, which is the least significant, multiplied by 8 to the 0 power. 2 is the next level of significance, so 2 times 8 to the first. 7 times 8 to the second. And when you multiply everything out and add them together, you would get the decimal output. So 467 in decimal is equivalent to 723 in octal. And your calculator does have octal output in the programmer mode. Okay. So look at the example. Now for the binary, similar to how we use it with the hexadecimal, let me move this down here so you can see. Instead of 4 bits like the hex, we would use 3 bits to represent octal. Okay. So when I have a 2-3 octal, like the example there, I'm going to work it out for you so you can see it's a base 8. We would then convert it into binary. So what you're going to do is you're going to take the 2 and you would convert it to a binary. So a 2 is represented with 0, 0, 0, 1, 0, right? Because the 1 is off, the 2 is on, and the 4 is off. There's only 3 bits in the octal. Okay, so let's do a 2 is this. And then we have the 3 is, what's a 3? A 1 plus 2, right? So a 0, 1, 1. Okay, so when you put it together, this is what you get, 0, 1, 0, 0, 1, 1. So we put a 2, 3 together, 0, 1, 0, 0, 1, 1. And you can practice looking at these or come up with your own and you can find out the answer. Okay, lastly, negative numbers. Okay, I mentioned to you how we would refer to this as sign and unsigned, unsigned for positive, signed for negative. Now, the way that we look at negative values is we're going to look at the 2 complement of it. Okay, so a 2 complement of it is that would be a way for the computer to see that it is a negative value of something. So when you have a 3 and you wanted to make it into a -3, the computer has to first flip the binary bits of a 3, okay, and then add a 1. So what do I mean by that? If you're looking at this example, well, let's do a 3 example. That's easy for you to see. So a decimal 3 is what? We're going to do a 0, 0, 0, 0. Let's say a 1 and a 1 like this, right? 1 plus 2 is a 3. So if we're looking at 2, 4, 6, 7, let me make it a byte so that way it's easy to represent. Now, in the process of converting a 3 to a -3, what the computer will do is the first complement, it's gonna take this and it's gonna flip the bits. So it's gonna take this value and it's gonna knot it, meaning that the 0 becomes the 1 and the 1 becomes the 0. So when it flips the bit, the first 0 is gonna become the 1 here. Okay. And then again, the next 0 and the next 0 and the next 0. So I have 6, 2, 4, 5, 6. Okay. And the last 2, because they're ones, it's going to become 0. So when we say flip the bits, all it is that it operates, it used the operator not. Okay. Then what it's going to do after that is it's going to plus a 1 to it. So it's going to, for the 2's complement, sorry, it's jumping all over the place. The 2's complement, we're going to do a plus 1. So we're going to take the value 1, 1, 1, 1, 1, 1, 1, 0, 0 that we found, and we're going to do a plus 1. With the 0 plus 1, so your output is going to be like that. So this represents the -3. Okay. So for your test and your quiz, future reference, you need to know how to do 2's complement. I will review this again next week when we work on some of the exercises, and then we will touch on operators and looking at truth table, okay, for the lecture, and then we'll work on the lab. Any questions? Okay, type in your name for the chat, please. Thank you so much for a good first day. And I hope you have a good night. And I will see you next week. Same channel, same time. Have a good night, everybody. You're welcome. You're welcome. Have a good night. Bye. You're welcome. Good night. If you have questions, you need help, let me know. I have a few minutes. But if not, have a wonderful night. Yes. You have a question? Do you want me to address it with everybody, or do you want to wait? You can unmute and ask if you like. I'm fine with that. Okay.
I think I had a question about the
Hexadecimal?
hexadecimal.
Uh-huh. Yes, Sarah.
I wanted to see, I actually wanted to see another example on how that looked like.
We will cover again on Monday. Okay? I
Oh,
will come. We will do more practice on Monday because, you know, we had a holiday this week. So I used my lecture for the second day. Normally I have like 2 days that I cover that. But yeah, we will do some exercises on Monday. I will help you. We will walk through, just like what we did earlier. We will go through each of the steps. Okay?
okay, it sounds good. Thank
All
you.
right. See you Monday.
Yeah.
Professor, I had a question.
Sure.
Hi, thank you for the code, though. I emailed you. I don't know if you remember in the morning.
Yes.
Yes. Okay. Yeah. Thank you for the code. I emailed you because I usually take the classes at Norfolk College, but I couldn't take this one because I didn't even know I needed this one until I talked to the counselor yesterday.
Yeah.
So now there's another problem is that I also need a CIS-11 class, and
Do you need a code for that?
yes, but the thing is that your classes are Tuesday and Thursday right, at night, but I won't be able to attend the Zoom meetings because I have work those 2 days.
Yeah, I think if you complete the task for the week by Sunday, because before I would take the regular attendance after each class, you know.
Yes.
But if you just complete the assignments, and you know, if you have questions, see me during office hours or send me an email.
Okay.
But yeah, just try to complete the task. I'll work with you on that. And because it is a regular meet class, but you're gonna find out that you should try to attend the Thursday if you can, because assembly programming, you know, or you can watch the video. I will post the video, but do watch the video because
yeah, I'll do that. But the thing is, I don't think I would be like on the
attending.
live. Yes.
Okay.
Yeah, that's
so
why.
but watch the video, and then because I walk the students through the lab, and if you have a hard time not, you know, if you don't watch the video, you're gonna have a hard time in the lab.
Okay, yeah, I will do that. But so I can, it's still at the class. You would be able to give me a code?
Yeah, 1 second.
Okay.
Yeah, I don't think Thomas is even connected. I think he's trying. So he might not even hear this, but 1 second. Let me get to my folder. Where did it go? Yeah, I had given out some waitlisted one, but okay. Ready?
Yes.
Okay, 8707.
07. Okay.
Yeah, you can try it tonight, and then it does take like about an hour or so before the Canvas loads.
Yeah, I saw that today with this class too.
Yeah, we met yesterday, and basically what I went over today is what I went over yesterday too, because in assembly you have to know how to look at the binary and the hex in the simulator. And I also posted a video. So when you look at the module, there's a page that says lecture video. On that, I linked my YouTube on there. So if you want, you can take a look at what we did on the video. And the same thing for this class. I uploaded the video, you know, later in the day.
Okay, yeah, I'll do that.
Okay.
Thank you.
All right.
Yeah,
Thanks for letting me know. No problem.
Thank you. No problem. Thank you.
Bye.
Bye. Good night.
Thomas, did you need help? I don't see you connecting. Okay, I'll see you later next week. Let me know if you need help via email, okay?